This question says, given a parabola with a vertex at 0, 0 and a focus at 5, 0, first off, construct the equation that defines the parabola. So let's take a look at those points on a graph. So we have the vertex at 0, 0. And we have the focus at 5, 0. And the way these parabolas work is the parabola grows around the focus. But whatever it does, it runs that direction. Now, this is an opening to the right parabola. So we basically have 4 different cases for us to look at. We have x squared equals 4py for p being positive. We have x squared equals 4py for p being negative. If x squared is 4py, it grows this way. If p is positive, it grows this way if p is negative. This example is y squared equals 4px. If y squared is 4px, again, we have 2 possibilities. If p is positive, it opens this way. Y squared equals 4px. If p is negative, it opens this way. P is the distance from the vertex to the focus. Sort of. Call it the directed distance. So let's take a look at what we have in our example. So we're here, this distance is what, 1, 2, 3, 4, 5, so p is 5. It's opening this way, so that's a y squared equals. P is 5, 1, 2, 3, 4, 5, 4px, 4 times 5 times x. Now is that 5 positive or is it negative? The focus is to the right of the vertex, so the p is positive. So what I'm going to have here is, I'm going to have p is 5 with an opening rightward parabola, so that the model I'm using is this one. So it says y squared equals 4px. Y squared equals 4 times 5 times x. It should be y squared equals 20x. So let's take a look on Desmos and see if that's the case. Y squared equals 20x. And indeed, there's the vertex, there is the focus. And we can see how that works. There's a couple points that are interesting here that we'll look at shortly. But the next thing I need to do is I need to find the directrix. So a parabola is the set of points the same distance from the focus and the directrix. So 1, 2, 3, 4, 5 units away, that's p. That is a distance from the vertex to the focus. If I go back this way, 1, 2, 3, 4, 5, the directrix has to go through this point. In this situation, the directrix will be a vertical line. So our directrix will be x equals -5. So this point is the same distance from the directrix and the focus. Now again, the point that I think is interesting is the point 5, 10. Why do I think that point is interesting? Because I want you to notice it is 10 units away from the focus. We see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's also 10 units from the directrix. It's obvious here that the distance to the directrix is also 10. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So this is a point on the parabola, as is 5, -10. So if we look at that, you'll notice this distance, 10 units away, 5, 10 units away, 5, 10 units away. This thing is actually called the lattice rectum. If I look at x equals 5, and I range it from -10 to 10, you may see that in some textbooks that that's the lattice rectum. But again, the points on the parabola are the same distance from the focus as they are from the directrix. This point, 5 units from this point, the vertex, 5 units from the directrix, 5 units from the focus. This point, 10 units from the focus, 10 units away from the directrix. So I have the equation of the parabola is y squared equals 20x. I have the equation of the directrix, which is x equals -5, and we have constructed a graph through those points. And if I didn't know that, okay, how could I find these 2 points on the lattice rectum? Let's talk about that for a minute. So if I didn't have these points, I would say, okay, if I'm measuring directly from here, how far do I have to go to land on the parabola? What would be the same distance away from here, here? How far would that be? That's going to define that point, right? Define the points 5, 10, 5, -10. Again, 10 units from here and 10 units from there.